I'm out on a project with our amazing crew to install 2 EP Cube battery backup units on this person's home in Palm Springs. Now, they have a massive existing solar system. We're talking about something over 15 kilowatts, and we're retrofitting over 30 kilowatt hours of storage for a whole home backup. And I'm going to take you through that installation process so you can see how awesome this product is and compact it actually is compared to the rest of the industry, because you don't find a battery solution like the EP Cube that can fit in a space of less than 4 feet. Yes, we're talking about less than 4 feet with these dual battery being set up. So why don't we take a look at some of the equipment. So here are the EP Cube components. We have all the battery modules for this project. We're going to have the hybrid inverter, the wall mounted brackets, and of course the smart gateway that manages all these devices. So there's a lot of things that we have to assemble on site when we're installing this equipment. Now, the first thing we do when we arrive is line up the gutter box that's going to house the main electrical connections from the main service panel and then to the smart gateway, and from the smart gateway to the emergency loads panel. This point of connection is critical, and ideally we try to always install it directly behind the main service panel in the garage. As most of the homes here in Southern California, we have all-in-one electrical panels, so we have to do it in this way, and it provides for a very clean installation. We've really dialed in the best method, I feel, for this. Now, this gutter box that we're using is 48 inches wide, which is perfect for the smart gateway and the emergency loads panel. And we put it in a way that we can relocate the circuits from the drywall to the sub panel, and you'll see that a little later. All right, so let's talk about the smart gateway, because this is the brains of any battery backup system, and that is no exception with the EP Cube. So as we move in, you can see there's a lot going on in here, but it's really not that complicated. So we have extended port 1 and extended port 2. This is where you would connect the existing solar system and a level 2 or a generator for, you know, additional support. So if we want a generator backup, we could use those ports. And then if we wanted level 2 charging during a power outage, we're going to connect it to this port. Now, for this particular customer, they do have a Tesla, so we will be connecting their charger here, so that way they have level 2 charging during power outage. And then this is where we're going to be connecting the 2 SolarEdge 7.6 kilowatt inverters. Right here is one of the EP Cube units, and then you have this DIN rail. This DIN rail is where we can add additional circuits to the load. So you can actually have up to 6 EP Cube units in total connected. That's 120 kilowatt hours roughly of storage capacity at a massive, like 40 plus kilowatts of power output. I mean, this thing can do a lot. You have the brains of the system over here. We have the emergency stop. You have cell modem, Wi-Fi. You have an Ethernet port if you want to plug that in. You got your consumption CT ports. So everything you need is right here in the smart gateway. This little toggle switch is the override that if you needed to bypass something in a particular situation, you could override the system. As you can see, this is to the loads, this is to the grid. So grid will come in here, it passes through the smart gateway transformer, and then it comes out and goes to the emergency sub panel. So it's a really clean, a lot of open space in here. I love the size of this. It isn't too big, but it isn't too small, because we have a lot of room, and when you're dealing with big 3/0 wire, you want that space for your connections, and that way you can bend them really nicely. As you can see right here, one is installing the brackets on the back of the smart gateway. It's important to note the orientation of the bracket. As you can see, there is a lower lip section right here, and that is, you want to make sure is pointing down towards these knockouts. And that's because it will slide onto the bracket once we install it on the wall and clip into place. Now here we are mocking up the bracket, and the EP Cube team includes a template, but we've done a couple of these and we kind of understand the exact location of installing these brackets. It's pretty simple. You measure from the bottom up to the highest bracket, and then you can pretty much map that out on the wall yourself. And it's not that hard. So what we're trying to do is make sure to land it on a stud. It's really important that it's at least on one stud on the wall. The unit is 24 inches wide, so you could land it on 2 studs if you have studs that are 16 on center. Not all construction is 16 on center, the majority of it is. So just keep that in mind. At least 1 stud is necessary for the weight of the component. But keep in mind, you also have that gutter box that does help support some of that weight, and you'll see how it all comes together here shortly. We're going to transition over to the knockouts because we have to put the holes in the smart gateway first before we mount it, so that way we can create our markings on the top of the gutter box for the raceway. All right, so we're going to start doing the holes in the bottom of the smart gateway, and the EP Cube smart gateway has template knockout locations already for you that are labeled. These are kind of helpful for those of you that aren't familiar with the equipment if you were learning how to install it for the first time. We've done a lot of battery backup systems, so this isn't anything new. What we're doing right now, as you can see, is just punching out little holes. These are 3/4 inch holes because we're going to use the Milwaukee punch out tool, which is really, really nice for metal. We don't necessarily need it for plastic. If we had a 2-inch bit, we could have done that, but we really like using our Milwaukee punch out because it just cleans, it creates such a clean cut with very little debris and very little effort. Obviously you still have to do that little hole, but that's about it. So he's screwing it in place and he's gonna punch it out, and we'll have a nice clean hole here. I would like to see the EP Cube Smart Gateway with no template on the bottom as an option, only because you'll find that you're not always lining up those holes exactly in the same places every time. Every project's a little different, and you'll find that we wanted to do 4 2-inch holes all the way across. So on the template for the Smart Gateway, there's actually only 2, which that's what Elvis is working on right now. And then the other 2 off to the right, those are actually 1.5 inches, and we wanted those to be bigger because we're dealing with whole home backup and a 15 kilowatt solar system and an EV charger. There's a lot of wires going in and out of this enclosure. So the bigger the holes, the easier it is to work with. Now, what we're going to ultimately do is just cut out the holes where those templates are for the 1.5 inches and kind of shift them a little bit. It doesn't affect anything. It's just a plastic enclosure at the end of the day. But it would just be nice if those little lips weren't on there, because then we could have full control over where to put our holes.
Now the Smart Gateway is pretty light. As you can see, Elvis is able to handle it all by himself, which you can't do that with some of the transfer switches. They can be pretty freaking heavy. You're too far to the, oh, there you go, perfect. So as you can see, it's all lined up. It's nice and tight. And so he's gonna mark the inside of these circles on the gutter box once he has it in position. And then from there, he'll be able to punch it out and then lock it in as well.
All right, so Elvis is pretty much ready to knock out the holes for the Smart Gateway in the gutter box. He's already punched the holes or drilled out the holes for the punch out tool from Milwaukee. Again, this is an awesome tool. I definitely recommend it if you're in this industry, because it'll save you countless hours and bits, to say the least, and it works great. And this isn't sponsored by Milwaukee, but we absolutely love this product, and we've been using it for over 2 years on battery projects. So now look how clean that hole comes out. You really can't get that with a bit. There's no debris all over the place, no hot metal flinging around. It's really, really clean and professional looking. And that's why we use it.
So as you can see, we are installing the wall bracket. And so the wall bracket is just there to help elevate the system off the ground. And like I was mentioning, not all garages are level. So this is a perfect add-on to the system to just give it some elevation. And it doesn't really extend it too much more off the wall. Typically when you're doing a wall mount, it's gonna be about 9¼ inches off the wall. When you do the wall bracket, you pump it up to about 10 inches. So it's not that much more, and it just looks so much better in our opinion, and you don't have to worry about leveling anything out. So with how the system is, it's modular. So we've already installed the base and battery module 1. There's no specific order to the battery modules, so you just install them accordingly. And they just snap into place. So as you'll see, Juan and Francisco will be opening up each individual batteries, connecting them to the wall brackets, and then just Lego stacking them accordingly.
So it's important to note that it can be a little tricky to line these up because each battery plugs into one another. There's no wiring that we have to do. We just have to properly land it in the next battery. So it's helpful in the beginning to have someone help line it up, and then it just snaps into place and that's it. And then you move on to the next battery.
So right now we're opening up the inverter for the first battery. This first battery is 4 battery modules. So we're looking at 13.3 kilowatt hours of storage capacity on that system. Within the box, Canadian Solar EP Cube includes the communication cabling and a transistor for that communication cabling. So it's important to keep that in mind, that you don't lose those components. So if you're looking over here, we've already taken them out. So this is your communication cabling, and this is the little transistor. And this little transistor is really critical for the communication of the system, and you don't want to lose it. So make sure to set it aside and in a safe place. And then you get about 30 feet of communication cabling, which is really nice. It's shielded and it's pre-labeled. Really nice touch. So coming back over to Juan, he should be opening up this box, and we should be able to see the inverter. Oh, look at that.
Look at that thing.
Ta-da! Yo esta se voy a ocupar ahí. Que se va a arrancar este, ¿no?
So this is going to be AC coupled, but if you were to connect strings directly to it, because it's DC coupled, you can connect your solar directly to it, and you have 4 MPPT inputs for this configuration, which gives you a lot of customization options for you. And then you have a fuse disconnecting here for the batteries. As you can see, there's just this little hole in this plug for the battery that will go in once we mount it up on the wall. We still have to install the bracket accordingly. So if we come over here, you can see all the batteries have plugged into each other through this little port, which is really, really easy, and because you just have your power, you have ground, and you have communication links going through each module and then up to the inverter.
No tengo que ponerle arriba. Sí. ¿Son estos, papá? Nunca me enciende.
Incencio.
So here's a little time lapse of a couple hours of work. Now, Juan is working on the bracket for the second battery. Francisco is working on some of the SolarEdge inverters. We have to put in a solar combiner box for them and bring them into the smart gateway as one circuit. And then also Elvis had installed the sub panel, and I really did not like the way it sat. It felt really high. I mean, it was within code. The maximum height for the top breaker is 75 inches, but I just did not like how it looked with the rest of the system. So we had a 12 by 12 4-inch pull box. You can see right now that's on top of the smart gateway. So I had him take down the sub panel so we can pass the wires for the home through that pull box. That 12 by 12 we'll install on top of the sub panel and then go from that pull box into the sub panel, because then the sub panel sits a lot lower and it's more in line with the smart gateway. It looked a lot cleaner, and while Elvis was kind of upset with me for having to redo it, at the end of the day he really liked the change that we made, and it just ultimately looked much better. One thing we've been trying to figure out how to do is little drywall cutouts, so we don't have to use a metal pull box. Drywall can be a little tricky. We're not drywallers, we're electricians. You know, we specialize in a different area, so we're not trying to be the jack of all trades, but you know, we would like to be able to do things that help take our projects up another notch. And at the end of the day, it's a balancing act between cost and look. So some homeowners don't really care how it looks at the end of the day, but we do, no matter what. And we want to try and give the best value we can for the best bang for your buck. So if we had to bring in a subcontractor to do a little drywall work, you know, that could be $500 to $1,000 to $1,500, you know, depending on the area, because we do systems all over Southern California, and we wouldn't likely be able to just have one drywaller that would go to each spot. So in the future, it's hopefully something we can, you know, work on doing, and maybe having as just a template triangular box that would go on top of the sub panel. Right now, Elvis is using that, you know, 12 by 12 metal box, which is used for electrical work. So, you know, it's just one of those little things. Now, some of the homes that we've done battery backup systems on, you'll find in new construction where they actually have already done the pull box. And that is really convenient because we can actually reuse that same pull box, because the main electrical panel actually isn't sitting in it. It's actually sitting in the studs, and then the pull box is behind it for the Romex. So on projects like that, we're able to cut open the drywall and pretty much put the sub panel right there in it. And then we still need the gutter box below it, and the smart gateway still goes in the same place. But, you know, it ends up looking a little bit cleaner at the end of the day. Every project's a little different, so you know what you're seeing here is unique for this particular application, but this is what we always strive for, is something really tight and clean, and just that's why we really like the Canadian Solar EP Cube. You couldn't get something like this with the Tesla Powerwall system. You're not going to get this with the Enphase batteries, and it's just really nice. This is 30 kilowatt hours of battery storage with 15 kilowatts of backup power. Now, if you did that with Enphase using the current IQ10T batteries, you'd need 3 of those units. Those are 50 inches wide each and 32 inches tall. So I could stack 2 batteries on top of each other where those EP cubes are, and got 20 kilowatt hours, but I only have 7.6 kilowatts of power output. So half the power output of what this customer is getting with this particular site. Obviously, this homeowner had SolarEdge, so we couldn't even do Enphase, so their option would have been the EP Cube, the Franklin Whole Home, or the Tesla Powerwall. Now, the Franklin Whole Home is 13.5 or 13.6 kilowatt hours, but it's a big battery, you know, it's 12 inches off the wall. So while we could have done 2 of those units, they wouldn't have fit in this space the homeowner wanted. Whether we tried to stack them on top of each other or side by side, it's just too tight of a space. He'd have to give up more of his garage space to the left. And the same is with the Tesla Powerwall. It's no different than the Franklin whole home battery, which is, you know, it's a square rectangular box. It's more wide and tall. It's you know, they're kind of in between, but it's not as deep. I will say the Tesla Powerwall is definitely not as deep as the Franklin. But I mean, at the end of the day, you can see this is it. That's the inverter going up on that second unit, and that's 30 kilowatt hours, 15 kilowatt hours of 15 kilowatts of backup. I mean, it's awesome technology that Canadian Solar and EP Cube have developed that you're not seeing in the industry. And if this homeowner wanted to add more storage, well, the battery on the left, we can add another battery module for 20. Doesn't add more wall, doesn't take away more wall space. We're just gonna move the inverter up. And then the battery on the right, the first one we installed, that one has room for 2 more batteries for 20. So this homeowner could go up to 40 kilowatt hours without taking up any more wall space left or right. We're just gonna increase the height of the batteries or the height of the system, you know, another 8 inches for each battery module. That's really, really nice.
Yeah. So here we are, finishing up the installation for day 1, and basically our goal for today was met. It was to put all the equipment in place, get it prepped for shutting off the power and getting it restored as fast as possible. So we try and prep the project in a way that we can keep the power off for as little time as possible, because it's hot out here in Palm Springs. So we have our gutter box, which is where we're going to be pulling the Romex through on the top. We're going to come into the sub panel. We've already landed our load connection from the smart gateway. So you can see those connections have already been made. We still have to connect the grid side, so we'll be doing that tomorrow when we shut off the power. We'll be connecting the solar backup. We'll be connecting that EV charger for level 2. We got the EP Cube over here. We have communication, and then we have the emergency shut off. So there's still quite a bit to be done, but at least the bulk of the project and all the equipment is in place. You can see this looks great from the inside. Again, you have multiple MPPT inputs. Here's for the communication. If you were to do a DC coupled system, because these are AC and DC coupled, but if you did DC coupling, you have TIGO integration for rapid shutdown compliancy with the optimizers up on the roof. Here's where your strings would plug in down here. This is for string 1 and 2. This is for string 3 and 4. This is the overcurrent protected device for the battery modules themselves. It's a fuse. So really clean, really nice on the inside of these units. And what we're going to do, and you'll see tomorrow, is how we wire the communication cabling with 2. So we're going to start with this unit. We're going to put a transistor at the end of the communication for the CAN bus. We're going to wire it over to this unit into the block, and then we're going to come out of the block and wire it into the smart gateway. It's really easy, and the Canadian Solar EP Cube team does a great job of giving you everything you need right out the box when you order it. So you don't need to go looking for that transistor. You don't need to go looking for the right communication cabling. They give it all to you. So that's your installation. This is 30 kilowatt hours. These 2 batteries right here, this is 30 kilowatt hours. If the customer had gone fully loaded, he could have had 40 kilowatt hours on the wall. In this same width, it would just been a little bit higher. He has plenty of room, and you're sacrificing very little space in consideration of other types of equipment on the market.